Welcome to another class. I'm Dr. B, your chemistry teacher. Today we're going to be discussing something very interesting, and that is collision theory. Collision theory is an extension from the chemical kinetics. Now, do not forget that as part of your contribution to what I am doing here, you need to subscribe to my YouTube channel, Dr. B Chemistry Classes, and do not also forget that you need to share it to your friends, share it to your colleagues, share it at your various platforms so they could be part of this. Don't forget also to like, leave a comment, and visit also my YouTube, my Facebook page, Dr. B Chemistry Classes, and also do the same thing by sharing, comment, like, and then follow. Now we are going to be discussing collision theory, and this, like I said, is an extension of the chemical kinetics. We are going to see that in chemical kinetics we discuss something concerning transition state theory, and today we'll be discussing something on the collision theory. They all have the same root. And what is that root? Rate of reaction. Rate of reaction. Remember that in the transition state theory lecture we had earlier before now, we had said that the transition state theory believes that there has to be an activation energy which a particular reactant has to possess, such that it has to be equal to or greater than the total highest energy of the reacting system, which is the transition state, before a product can be formed. Now, even though the collision theory believes that there has to be an activation energy that will overcome the total highest energy of the transition state, it also believes that that is not enough. So, the collision theory believes that for any chemical reaction to take place, there has to be two things that must come to play. And one of those things is the activation energy, just like the transition state theory had discussed. And the second one is the collision of molecules. So the collision theory believes that there has to be activation energy, there has to be collision of molecules. And it is not enough for molecules to collide, but there has to be an effective collision. That is to say, before a product can be formed from any chemical reaction, there must be an effective collision of the molecules of the reactant. Now let us put down something to understand what we are talking about. Now, supposing you have a reaction, let's say you have a reaction of maybe NO2 plus NO2 to give us 2N2O2. Let's say we have this kind of a reaction. Okay, now this reaction is possible because there is an effective collision according to the collision theory. So if we demonstrate this, let's say we have this, and then we have this. Let's say we have this. This is NO2. This is NO2. Okay, now it's reacting, and it gives us this. Let's say it gives us this, and then it gives us this. Okay, and then finally it gives us this and this, and of course this nitrogen. Okay, now if you see here, if you see here, you see this is NO2, this is NO2, and here there is an ineffective collision. You see? So you see that there is no effective collision here, because there's a problem also with the orientation. Because when you talk about effective collision, we are talking about proper orientation. Okay, so it means that it is not enough for you to talk about collision, molecules colliding, but you must also understand the fact that they must be colliding with their right orientations, at their right positioning for a product to be formed. That is what collision theory is all about. So if we needed to form produce this N2O2, and then we decide to have these two molecules. This is nitrogen, this of course is oxygen, all right? And then you can see that the oxygen is rather trying to bond with the nitrogen. In this kind of collision, you see that the orientation is wrong because of the ineffective collision which come from the wrong orientation. You cannot have product. There is no product. But if you rather have something of this nature, okay, and then we have another one of this nature where this is NO2, this is NO2, and then they are actually reacting, and then here we have this. Okay, here we have something of this nature. Okay, let me make it a bit clearer. Here we have something of this nature, and then here we now have this. Okay, now here we still have this. You can see that here there is an effective collision. There is an effective collision, and here there is product that is formed. Here product is formed. You can see that. So this product, of course, that is formed here is N2O2. Now you can see that because there is a proper orientation, the nitrogen is going with the nitrogen, bonding with the nitrogen. Of course, it will give you the nitrogen double bond. So the nitrogen is bonding with the nitrogen. So there is an effective collision. So product is formed, which is this. But where the orientation of the molecules is wrong, the position of the molecules is wrong, no matter the collision, you cannot have a product that is formed. And that is exactly what the collision theory is talking about. So according to the collision theory, there must be for any chemical reaction to take place, for product to be formed, there must be what? An effective collision, and there must be an activation energy of the reactant. Okay, now having understood what this is all about, it's important for us to know that there are assumptions that govern the collision theory. And one of those assumptions is that if you want to have a greater collision, then there must be an increase in the number of reactant molecules. But of course, it's very obvious. Okay, so just like when you look at factors that affect the rate of a chemical reaction, one of those factors is increase in the reactant molecules, and that is because of what? The increase in the concentration of the reactant. So if there is increase in the concentration of the reactant, there will definitely be increase in the number of reactant molecules. And once there is increase in the reactant molecules, then there will definitely be increase in collision. And definitely there will be also increase in the collision, in the effective collision that will lead to the formation of product. That is one of the assumptions. So where you have increased number of molecules, you expect increased what? Collision of molecules. Now that's my one. Number two, collision theory also believes that for every reactant molecule to undergo, a collision for product to be formed, then there has to be sufficient what? Energy. There has to be sufficient energy. Remember that where there is sufficient kinetic energy, there is also a tendency of increase in the collision, in the nature of collision of the molecules. When we say collision, we're talking about the striking of the reactant molecules with themselves and the walls of their container. And that form a basis for the rate of a reaction and the product formation. So you also believe in the second assumption, the collision theory believe in their second assumption, that there have to be a sufficient amount of energy for the reactant molecules, that is the kinetic energy for the reactant molecules, to do what? To collide with each other. Now another assumption is on the base of temperature. The collision theory also believes that where there is increase in temperature, there is also increase in the rate of collision of reactant molecules. But of course, in your factors affecting the rate of reaction, temperature is one of those particular factors identified. So it means that if reactant molecules must do what? Must collide with each other, you must have to do what? Increase the rate, increase the temperature. And of course, it is when you increase the temperature that you also do what? Affect the kinetic energy of the molecules. So both of them work hand in hand. And finally, it also believes that there is need for what? Activation energy of the reacting system to be overcome. So it means that if you by chance want to do what? To have a product being formed apart from effective collision, those particular reactant molecules must also possess enough energy, enough activation energy to do what? Allow them to overcome the greater amount of energy at the transition state for the product to be formed. Now, these are the four basic assumptions that govern collision theory. I will repeat myself. One is that if you want to have increase in collision of molecules for product to be formed, there must be increase in the number of molecules in the reacting system. Two is that if you want to also have increase in the collision of molecules for a product to be formed, there must be sufficient energy, kinetic energy for the molecules. Three is that if you must have increase in the number of molecules in the reacting system colliding, you must have to increase temperature of the system. And if you must overcome the amount of energy at the transition state because of the increase in temperature for a product to be formed, then you must do what? You must make sure there is a minimum amount of energy for the effective colliding molecules to use and overcome that particular transition state temperature for products to be formed. Now, that is interesting. But the basic thing you must understand from our lecture today is that unlike transition state theory, the collision theory believes that there must be colliding of molecules for what? Product to be formed. And it's not just molecules colliding together, but there must be an effective collision of molecules. And that is why we have this diagram that explains this effective collision of molecules. Where we have ineffective collision because of wrong orientation, there is no product that is formed. And like I said, if we are talking about effective collision, we are talking about right and proper orientation of colliding molecules. So if the molecules are only colliding, it is not enough. They cannot form products except if they are colliding in their right orientation and positioning. I'm sure we have learned something from the collision theory. But before I go, I'm going to leave you with what we call the collision frequency, which defines the collision theory. So we are going to see what defines the collision theory, which of course is the collision frequency. Now, the collision frequency is simply explaining the amount or the frequency of the colliding molecules. Okay, frequency of molecules that have to do what? Collide for a product to be formed. That is all that it talks about. Okay, explain the amount, the frequency of the colliding molecules with respect to seconds and volumes of the reactants. That is just it. So when we write this equation that depicts the collision frequency, we will see that the collision frequency K will be equals to let's use the factor Z, A, B, what is common, P, and the exponent of minus EA all over RT. Now, this equation is the collision theory equation the collision theory equation. And this equation is the equation that you can use to obtain your what? Collision frequency. So here ZAB simply is the collision frequency of the product of the reactants, okay, of the reactant AB. And then this value is your steric effect, or you call it steric factor. And then your EA all over RT is simply defining, let's say molecules with enough energy to overcome the activation energy of the system. Okay, but of course you know that R is your gas constant and T is your absolute temperature. Now with this equation, this is the collision frequency of the reactants A and B, and I have mentioned that collision frequency is simply the frequency of the reactant molecules per second and per unit volume of the reactant. Okay, that is what this means, collision frequency. All right, that is what the frequency of the colliding molecules per second per unit volume of the reactants. And it is a very important factor because it is that which helps to tell you the number of molecules, effective molecules that took part in the reaction. And then this, of course, is steric effect or steric factor. I'm sure you heard that word steric factor before, or steric effect. It is simply a measure of what a measure of the number of molecules, colliding molecules in this particular instance, that collided with the right orientation and positioning in order to form products with the right geometry. That is to say that steric effect simply talks about geometry. Remember that we had said that collision theory believes that there must be effective collision, which means there must be molecules colliding with their right geometries and positioning for product to be formed, and that which defines that geometry is the steric effect or factor. And we said the steric factor is simply a measure of the number of molecules, or colliding molecules, that collided at their right orientation and positioning to produce products with their right geometry. That means that if they do not collide, if the colliding molecules do not collide with their right orientation, they can form products that are not actually their what? Their right geometries. And remember that geometries or shapes of molecules is very, very important because it also defines the reactivity of molecules. Now, this, of course, we say is simply the molecules with enough energy to overcome the activation energy of the system. Now, with this, we will end our lecture here. You can be able to compare collision theory with transition state theory. Do not forget to like, do not forget to share, do not also forget to subscribe. Very importantly, do not forget to share with your colleagues, share with your friends, share with your groups, so they could also be part of these particular studies that we are doing online. Until next